Okay, today we are going to show you how to properly service an air conditioner. We're going to show you what the tools that are required to do the job properly are, and how to actually service it correctly. So now we're going to start with gauges. Now I prefer the field piece gauges because they do a lot of the calculations for me. I have my temperature probes built right into it, so I prefer this. This one I have hundreds of different refrigerants. I can do my wet bulb, my dry bulb, everything all in one thing. So that's why I prefer these. In the old days, you'll find that a lot of technicians will use the old gauge, the old manifold gauges. These work, but especially if you're using these, there's a lot of extra things that you have to have and do in order to get the exact same information that my field piece gauges will give me. Such as, you'll need temperature, a K-type temperature probe, because you have to be able to read temperatures in order to determine proper superheat and subcooling. Now, K-type is a good surface temperature. It's a true surface temperature type probe. Some people use J-type, but I prefer K-type. They're very accurate. You'll need a multimeter that can read temperature as well for this particular setup. But if you're not using this old style, then you just need your field piece gauges, and that's primary. The next thing that you need is a amp probe, being able to show amps, volts, everything to further diagnose the system. And you'll need, the most important thing, a scale. If you do not use a scale, then you cannot tell how much refrigerant you've used. The EPA requires that a scale is used every time. The new requirements are that you're supposed to write down exactly how many pounds and ounces you used at every customer's house to be able to track every ounce of R22. Now, I know lots of technicians do not use this. They think it slows them down or whatnot, but if you don't use a scale, you're lying. And that is the number one thing that gives this industry a bad name. You need to be able to do your job correctly. You know, not only for accuracy, it makes the customer happier, but you know, when you're always lying about what you do, it really tears at your morale. So make sure you do it right. That way, if someone like myself comes behind you and disproves you, you know, if you aren't using scales and whatnot, believe me, I'll be the first one to say, hey, didn't know what he was talking about. You must have scales. So the next thing that you must have is coil cleaner. I know too many technicians that do not clean the condenser coils and the evaporator coils. All they do is just add refrigerant to the system. This is the most important thing out of all of this, because with dirty coils, the rest of your data is all bad. If you have bad data coming from your coils, bad data spreads throughout the rest of the system. You cannot have your refrigerant charge properly done with dirty coils. So you want to, and even if they look clean, I always clean my coils so that I can be assured that they are as clean as they possibly can, so that I can get maximum efficiency from the air conditioner, and also make sure that I have good data. Because with good data, I have good results. Bad data, you have bad results. Too many technicians go out and they will be there for a service call where it's not cooling. They quickly hook up their gauges and they see, oh, well, you're low on refrigerant. Some of them will even use superheat and subcooling, but those will still be wrong if they do not have clean coils. I believe I show in another video exactly what happens when you have dirty coils. Big difference in your subcooling and your superheat based on dirty coils. It really hurts the efficiency of the system. So enough on that. But so now, first thing we're going to do is we are going to clean the coils because I want these as clean as I can. I don't want my equipment to be hooked up and get all wet, and so we're going to clean these coils by spraying. The most important thing is read the instructions on the coil cleaner. Every coil cleaner is different. I do not use acid-based coil cleaners because they're too harsh on the coils. They eat away at they cause a chemical reaction with the aluminum, and they end up destroying the coil. The only time I would ever use an acid-based coil cleaner is when I had a severely clogged coil, one that probably hadn't been cleaned in 20 years. But even then, 9 times out of 10, I can use my non-acid-based coil cleaner and do just fine. So we're going to spray our coils very liberally, and we're going to get all the way up and down, and I'll go over this several times. All the way around. So, also, I do let it run for a little bit while I'm spraying it, just to help the cleaner be pulled through the coil. A lot of people say, no, never spray the coil while the unit's running. Definitely don't breathe the fumes coming off of it, but I spray it while it's running just to help pull the cleaner deep into the coil, and then I turn it off, spray it some more, and then I let it sit. So while we're letting it sit, I'm going to grab the hose and then we're going to thoroughly wash this coil, and we'll be right back. Okay, so we're going to spray the coils, and we're going to spray it with just a light spray. You don't want to spray it too hard because you can cause the fins to bend. As you can see, this one's already got bent coils or bent fins on it, so we don't want to further cause any problems by having the water spray so hard that it actually bends the fin. And we're going to want to thoroughly spray this down several times. You don't want to spray it and very quickly and then just walk away, because if you have residue left on it, even if it's a non-acid, it still can cause corrosion and damage the condenser coil. I like to spray it until you can pretty much tell when you're not getting any more of the coil cleaner, when the coils are fairly clean and you're not seeing the actual chemical coming off the bottom of the coil. Okay, so once we have clean coils, the next step is to actually let this unit run for 15 minutes, because the evaporator, the condenser coil has to actually evaporate all the water that we just sprayed on it before we get true readings. If you take readings right after you've sprayed down a coil, your superheat is going to be lower, your subcooling is going to be dramatically lower, because you're actually reading the evaporation of the water on these coils, and it's not the true state of the air conditioning working. So you want to make sure that this runs for about 15 minutes for multiple reasons. Number one is you're really not reading the true state of an air conditioner or a heat pump until it has been running for 15 minutes. That has given the refrigerant plenty of time to fully cycle through the system, and we are seeing the true evaporation and condensing of the refrigerant in the system. So we're going to let this run for 15 minutes, get it up to speed, and then we'll be right back. Alright, so the next thing that you're going to want to do is connect your gauges once the system has been running for 15 minutes. Now I've got my gauges connected, I've got my temperature probes connected, and I've got my one probe connected to the suction line, which is the larger line. I've got another probe connected to my liquid line, which is the smaller line. It's important to have both of them on there, but first, and the next important thing is we have to determine what type of air conditioning system this is, because you cannot properly charge a air conditioning system unless you know, is it a fixed orifice, or is it a TXV, is it a capillary tube, or whatnot. So in this particular case, I've already looked at the evaporator, because you will go to the evaporator, or you can even, some of them will have the information posted right here on the data plate, which will tell you whether or not it uses a TXV, or if it is if it's a piston-driven system. But I always like to verify, because I've gotten plenty of homes where they use a system that was designed for a TXV, but nobody installed the TXV. Some installers don't understand TXVs, and so they've never installed it. So it's always important to take a look at the coil. In this particular one, we've already looked at the coil, and we found that this is what we call a piston-driven system. It means that instead of a TXV, we have a piston that is helping to cause the conversion from liquid to gas in the evaporator, where liquid is being forced through the piston, where it begins to change its state. When you're forcing the liquid through and into smaller and smaller space, and then it releases into a much larger space, you can have very rapid evaporation. That's why the coil inside is called the evaporator. So we're going to turn the system back on, and then we're going to, the next step, if you have a piston-driven system, is to take wet bulb. That's the very next thing that you're going to do. And you're also going to have dry bulb outside. So we're going to go take the wet bulb. We'll show you how to do that, and we'll be right back. Okay, so we're going to take the wet bulb. I'm going to show you the old-fashioned way. There are a lot of different ways to take the wet bulb. This is probably one of the easiest ways. It used to be that we would take a wet piece of cloth, put it in what we call a sling cyclometer, spin it around really, really fast, and that would give us our wet bulb. Now with the sensors and temperature probes, we can simulate that by using what we call a wet sock on a K-type thermistor. So this one, you get it thoroughly wet, and then you're going to insert it into the return grill, and you're going to select your temperature, and basically what is happening is the air rushing by this wet sock after it's been in there a second is causing the evaporation. So what we're truly finding with wet bulb is what we call the evaporation rate, or the evaporation temperature. So right now we are showing a 66.9 evaporation rate, and so that's the easiest way to get your wet bulb with just basic stuff that would come with like, let's say, a filled piece meter. These probes come with your meters. There are specific little handheld sling cyclometers that are even more efficient, a lot easier. Some people even say more accurate. I've been doing wet sock for such a long time. It's just what I do. So that's the way I prefer it. But if you want to grab a little digital one, hey, make sure that whenever you're dealing with digital equipment, make sure that you have it tested and serviced regularly, because I have found I used them at one point, and what happened was my sensor got dirty or whatever the case may be, and it just wasn't giving me true readings because of that. And so, like I say, bad data in, bad data out. So that's why I kind of prefer the old way, just because it's accurate, close enough, and you don't have to worry about changing the batteries, except for on your meter. So we're going to take the 65.9 wet bulb, and we're going to add that into the field piece meter. That's going to give us, combined with the outdoor, what we call dry bulb, where we will take temperature without the wet sock. That will give us what we call a dry bulb temperature, and when you combine those, it will give you what we want is our desired superheat. So we're going to go back and enter our data, and we'll be right back. So we're back at the meter, and I've got it in my wet bulb selection. And so what I'm going to do, I've removed my probe, because otherwise it'll automatically try to fill in my probe's data. And so I'm going to hit enter, and we're going to change this over to 65.9. And then we're going to take the outdoor temperature, which it's already reading that, so we're at 82.4. So I'm just going to cycle through and enter, and went a little bit too far. And so it's giving us a 16.8 superheat is our desired superheat. Now plug back in our temperature probe that's on our on our suction line. So when you are looking for superheat, you're going to want to have your temperature probe on your suction line a few inches away from the service valve is the best place. Some people say 6 inches away from the service valve is the best place to read that. So in this particular case, we are actually overcharged. Now that is because we have too much refrigerant. It is coming back in its liquid form, and we are over our desired superheat. The service call was originally that the house was very humid, very muggy. We're in the deep south here. Humidity is a huge issue. For some people up north and whatnot, actually overshooting your superheat's not a big deal. But here in the south, you got to get your superheat just right, or we'll not remove as much humidity from the air as it possibly can. The next thing is that it seems to run a lot. It's running almost all the time. These are very typical symptoms of an overcharged air conditioner. Now, if you look at the pressures here, if you were not taking your wet bulb, you weren't using your temperature probes and whatnot, you would think, a lot of the old timers or rule of thumbs, would say, hey, my suction's 70 and my head pressure is 200. Hey, I'm good. It's perfectly fine. These people just don't know what the heck they're talking about. It's working. You know, I'll just tell them, you know, oh, I added some more, or whatever the case may be. Charge them some money and go. That's the difference between a great technician and a bad technician, is having all the information. So, by actually removing the extra refrigerant, that will greatly improve the efficiency of the system, making it work less, and drastically, and I mean drastically, improve the humidity reduction at the coil. So right now, because that's why we don't have a can of R22, I never hook up my refrigerants until I know what I need. So right now I'm going to run and get a reclaim tank. We're going to remove a little bit of the refrigerant until we get to the proper superheat. So we'll be right back. Okay, so we're hooking up our reclaim tank, and we're going to set it down. You don't want to set anything really on top of the airflow. That will also cause a bad data. So we're going to open our liquid side and basically dump a little bit, very slowly, dump a little bit into my reclaim tank, and you'll actually begin to see numbers changing. So we're starting to have our, it'll fluctuate up and down, up and down. So you have to be patient, you have to wait. This process will probably take 15 to 20 minutes to do this. And so we won't make you sit through all that. We'll be right back once I've got it pretty close to our superheat, target superheat, and then we'll show you all the differences. Okay, so we've added the refrigerant. When it comes to superheat, really hard to get it dead on, but you can get really close, as you can see. Just adding a little bit of refrigerant. I've even overshot it just a teeny bit. As long as you're within plus or minus of 3, that's usually the rule. You know, so now if I go to like 10 superheat, I've actually added too much and I need to remove just a little bit. But being at 14, 15, that's perfectly fine. And so once we've gotten it to the proper superheat, kind of remove our hose. So as you can see, basically we only added 5 ounces to the system. Hardly any, you know, 1/3 of a pound was all that was required in order to get this to the proper amount. A few ounces makes a big difference in air conditioning. So overshooting is harmful to the compressor, puts it under a heavy load, so it makes it draw more amps. It's actually worse to be overfilled with refrigerant than it is to be underfilled. Now there's a point where it becomes so low that it begins to freeze up, and then that's detrimental to it too, but I'd rather see a low system than an overfilled system. So I hope this was able to show you exactly how all this is done, and this is the proper way to do it. And if you have any questions or comments, feel free to let me know. As always, like and subscribe, and have a great day.